Hello everybody. Today I want to share how AI is fundamentally changing the game for refactoring and large-scale migrations. We are not talking about simple autocomplete anymore. We are talking about AI systems that can analyze thousands of files, understand complex dependencies, and automate transformations that previously took teams months or even years. In the next 20 minutes, we will explore how tools like GitHub Copilot, OpenAI Codex, and other specialized migration frameworks making these complex transformations faster, safer, and more manageable. And more importantly, I will share some real-world lessons learned from my experience and show you how to balance automation with human oversight that is still essential. So, when I hear about refactoring with AI, I always think about these three. None of it worked, but boy was it beautiful. No, but seriously, the idea of AI refactoring has been around for a while, and early attempts were clunky and error-prone, and often generating more work than they saved. But fast forward to today, and we are seeing AI tools that can handle complex tasks with impressive accuracy. So there is a way forward that we will explore today. But first, some context. Large-scale code migrations and refactoring projects are just notoriously difficult. Legacy system modernization projects have more than 70% of failure rate. It is like more than 2/3. And some examples of these are Facebook transition to React 16, architectures that took like more than 2 years, and Google's recent research that showed that large-scale migrations traditionally require hundreds of software engineering years to complete manually. But here's what changing. Google recently used AI-powered tooling to reduce migration time by 50%, while having AI generate 74% of code changes across more than 500 modifications. And Reddit used AI to detect anti-patterns and refactor across 2,000 repositories efficiently. These are not just isolated success stories. They represent a fundamental shift in how we approach code transformation. The challenge is not just scale, it is complexity. Modern applications have intricate dependency graphs, business logic scattered across multiple layers, and the constant pressure to maintain service availability during transitions. Traditional tools like static analysis and search interpolate script just cannot handle contextual understanding required for large and safe migrations. So, here's what we will cover in the next 20 minutes. One is types of refactoring that AI can do with some examples. 2 is AI-powered refactoring tools. And 3, essential rules for LLM-powered refactoring. And 4, some just final thoughts and recommendations. So let's look at how AI can be used for refactoring tasks. AI excels at 3 critical types of large-scale refactoring via previously manual nightmares. First is framework and language migrations. AI can handle complex syntax transformations, API migrations, and even cross-language conversions. We are seeing successful Python to Python sequence migrations, AngularJS to Angular transitions, and Java version upgrades that maintain business logic integrity while adopting modern patterns. Second is architectural transformations. It is the most impressive capability, breaking monoliths into microservices, extracting shared libraries, and restructuring for better separation of concerns. AI can analyze call graphs, identify boundaries, and suggest database decomposition strategies. And third is performance and security improvements. AI tools can identify performance bottlenecks, suggest algorithmic improvements, and even detect security vulnerabilities during refactoring. They are particularly effective at replacing inefficient patterns with optimized alternatives while preserving functionality. So, what tools are available today that can help you with these complex tasks? Most prominent, of course, is GPT-5 Codex. It is specifically optimized for complex software engineering tasks. It is not just your basic completion tool. It can operate autonomously for up to 7 hours, handling multi-file changes spanning across thousands of lines. In direct evaluation, GPT-5 Codex achieved more than 50% of accuracy compared to 39% for standard GPT models. And there is, of course, GitHub Copilot. It has evolved beyond individual developer assistance. Enterprise version can now include specialized refactoring capabilities that understand your entire codebase context. It can suggest architecture patterns, identify code smells across repositories, and propose systematic improvements. There are also specialized migration tools, like, for example, SourceGraph, Aviator agents, and vFunction. They are purposefully built for large-scale transformations. Aviator agents, for example, act as an intelligent migration assistant, finding references, understanding dependencies, and breaking down large transformations into manageable chunks.
Yeah, I mean, there's some great talks here, but what I'm really looking forward to, and I've been to a couple of these GitNation shows, panel talks, when you're with a whole bunch of other people, you're getting these great conversations going on. That's really fun.
So, before we dive into examples, let's establish the foundational principles that separate successful AI refactoring implementations from disasters. Based on Google research and just industry best practices, here are some 6 non-negotiable rules. And first is the obvious one. It is to preserve, above all, the behavior. Refactored code must behave identically to the original under all conditions. This means that comprehensive regression testing, edge case validation, and performance benchmarking are just required. If you can't prove behavioral equivalence, do not deploy the change. Rule 2 is about context. It is king. And LLMs need extensive context to make good refactoring decisions. Never pass just a single function or class. Include related files, dependencies, test cases, and even documentation. In Google documentation, their success came from providing up to 50 related files for just one transformation. The more context you provide, the better refactoring suggestions. Rule 3 is to implement smart retry mechanisms with learning. Do not expect perfect results on the first attempt. Build retry loops that learn from failures. When an LLM makes a mistake, include that error information in the next attempt. Google migration system used iterative prompting, where each failure informs the next attempt, dramatically improving success rates. Rule 4 is to never trust. Every AI-generated refactoring must pass through multiple validation gates, syntactic correction, semantic correction, and business logic preservation through end-to-end and unit testing, and performance impact assessment through benchmarking. Up to 76% of initial LLM refactoring suggestions can be hallucinations, so validation is absolutely crucial. Rule 5 is to start small and scale gradually. Begin with low-risk, isolated components. Extract simple functions before attempting architectural transformations. This builds confidence in you and proceeds to help you with identify edge cases and before technically critical systems. And final rule is to document everything. Rationale, process, and changes. AI refactoring can make changes that are not immediately obvious to human reviewers. Document why refactoring was needed, what AI changed, and how the new code improved the original. This documentation is crucial for maintenance and debugging. So, framework migrations represent one of the most challenging yet impactful refactoring scenarios where AI truly shines. Unlike simple syntax changes, framework migrations require understanding of architectural patterns, dependency relations, and subtle behavioral differences between old and new paradigms. And it is just perfect for AI. Why? It is because AI excels at pattern recognition and can simultaneously handle multiple transformation rules across thousands of files. Where human developers might miss an edge case or just inconsistent apply migration patterns, AI maintains systematic consistency throughout the entire codebase. Some real-world impact is AngularJS to Angular migrations, and traditionally they can take 6 to 18 months for enterprise application. With AI assistance, team can complete them into 2 or 4 months while achieving the higher code quality with fewer regressions. Some key AI capabilities is pattern recognition. It identifies patterns across multiple services, service structures, and architectural boundaries. It can also use syntax transformation for automated conversion and directive patterns and injection mechanisms. There is also type safety introduction in the case of JS to TS transition. So seamless migration from JS to TS with proper interface and definitions. And testing migration for automatic updates to test suites that maintain behavioral coverage. So let me show you a real AngularJS to Angular migration. This example demonstrates how AI identifies component patterns and converts service injection patterns, updates template syntax, and handles the active programming model, transitioning while maintaining identical business logic and adopting TypeScript and modern async patterns. So here I have a deliberately legacy AngularJS repository, essentially. It is quite a small app, as I like. It is obviously not a production code from anything that I can show, but it is something that I quickly did for this presentation, and I can show how it works by running start and seeing what we will here have. So it is a quite small app that will essentially a user directory. You can activate or deactivate users and just do whatever and preview their data. So let's show by how using GPT-5 Codex inside Copilot, we can quickly and efficiently migrate it to Angular from Angular.js pattern. I here have quite a comprehensive prompt that we can use, and that should do the trick. You can see that it has mission statement, it has all of the context and requirements, and it has scope, patterns that it should follow, and code quality verification and output requirements. So following the rule about context, let's add everything that we have here, which would be an SRC folder and just all of the files from the root. We should actually just have a package, and that should be more than enough. And let's run it. This may take quite a while, so I will probably just cut to the point where we got the result. So after less than 30 minutes, we are back, and it did quite an impressive job. It revamped the whole application from Angular.js to Angular and updated and even added the tests that are passing. It got a bit frustrated on the npm install command, which was running for quite a long time. And yeah, I guess it can happen, but it is working, and we can see that it does a pretty impressive job of just doing this migration in essentially one command, which is impressive. And let's get back to the presentation. Next is the complexity challenge. Large monolithic applications can have thousands of classes with interactive dependency graphs. Traditional refactoring approaches require manual analysis, service boundary identification, and careful extraction planning. Processes that are both time-intensive and error-prone. Modern AI tools can analyze entire code bases simultaneously, identifying patterns that span multiple modules, understanding data flows across layers, and recognizing coupling patterns that indicate optimal service boundaries. Some enterprise success metrics are, for example, Pinterest that used AI to break their monolithic Python codebase into 200 microservices, reducing deployment times by 70%. Shopify that used AI-assisted extraction for their checkout service to reduce code complexity and improve performance. And Netflix that used automated boundary identification that helped decompose legacy systems with really high accuracy. Here's a practical example of how GPT-5 Codex can handle API refactoring scenarios. This code represents a typical enterprise controller with multiple dependencies: modification, capture validation, database operation, and external services. While this is simplified for demonstration purposes and by no means it is production code, it is something that I've used for hobby project quite a while ago, and you can see that it did not age well, as it has a quite prevalent back in the day issue of having a doom stack of essentially then callbacks. This is something that we can use for a great demonstration here. As what we can do is I here have quite a simple prompt, far simpler than the one used last time. And you can see that I'm also following the rule and adding all of the needed context. So the goal here is to refactor the component and to replace async await for those essentially a stack of callbacks. It will be something that we can start small, and ideally the next part would be to resolve the callback issue and go beyond this component and do it across the whole code base so that it will be far manageable. But for this demonstration, we will do only the async await one. So let's run the command, and I will get to you when it is done. And in less than 5 minutes back, you can see that it did a pretty good job of refactoring the quite a complex component and using the async await syntaxes in it. You can see that our primary metric was passing the tests, because it also has quite a comprehensive test battery covering all of the edge cases. And what we did essentially is did a refactor, and then it tried to do to go through a test battery, but it found an issue, and it is a perfect example of it trying to get through the issue. So it has been trying to run tests through different scenarios, and I'm pretty sure in that case it was just a terminal issue, and after trying it for a while, it suggested that yeah, it just fails with code 130, and you can try it manually. I did try to run it manually, and it passed. So in that case, by our standards, it is a perfect completion, as we did follow all of the rules, and we got the result we expected. We have started small and we got our refactoring. We now have the outline of the next steps that we will pursue. But the most successful AI refactoring applications are just not standalone tools. They are integrated into existing CI/CD pipelines. The integration provides several critical capabilities. For example, automatic quality gates. Those are AI-powered static analysis that runs on pre-commit hooks, catching issues before they reach production. Tools like, for example, Thorold automatically fixes on cube violations, while specialized linters understand domain-specific patterns and business rules. They can also be used for continuous refactoring. Instead of just one big bang migration project, AI enables you to have continuous improvement, small refactoring changes that are proposed, validated, and deployed as part of regular development cycles. This reduces risks and maintains business continuity. They are also really great for testing and validation. AI can generate comprehensive test suites for refactored code, including edge cases that humans might just straight up miss. And those tests validate that the refactored code behaves identically to original while maintaining the architectural requirements. So here is some really crucial point. AI does not replace developers, it amplifies their capabilities. Most successful implementations maintain strong human oversight throughout just several mechanisms. First of all is, of course, review process. Every AI-generated change must go through human review. This is a must. But the focus shifts from writing code to validating business logic and architectural decisions. There is also a domain knowledge integration, and AI tools need to have a context about business rules, security requirements, and organizational constraints. Most effective approach involves training AI on project-specific patterns and coding standards. And risk management. Implement staging environments specifically for AI-generated changes. Use canary deployments and automated rollback procedures. Maintain feature flags and allow quick disabling of problematic changes. But AI refactoring is also not without challenges. AI can hallucinate imports or miss domain-specific constraints. It can mess up complex business logic, and it can oversimplify or misunderstand it. Integration points between systems require careful human validation. And there are some organizational challenges as well. Teams need to be trained on AI, assisted with development workflows. Code review processes must adapt to new and evaluate new AI-generated changes. And there is just cultural resistance to trust in automated transformations, which I can completely understand. But there are some mitigation strategies for that. Implement comprehensive testing protocols for AI changes, maintain hallucination watchlists for common AI mistakes, and establish clear governance over AI tools. And always invest in team training and change management. So, the trajectory is clear. AI will become increasingly sophisticated and understanding code context and business logic. We are moving towards AI agents that can handle multi-repository transformations and architectural decisions with minimal human intervention. And some immediate action items for that is to start small. You can begin even today with low-risk refactoring tasks to build team confidence. Also invest in training, develop team capabilities and AI-assisted development. You can also start establishing governance, creating clear policies for AI tools usage and output validation. And start building infrastructure, implement AI environments and automated testing for AI changes. Fifth is to measure everything, track both technical depth and reduction for developer productivity. So, how you can prepare for future? Experiment with multiple AI tools that understand their strengths, develop internal expertise and prompt engineering and AI model configuration. So, some main takeaways is that AI-powered refactoring and migration tools are no longer experimental. They are production ready now. You can try those technologies to dramatically improve your team's ability to handle large-scale code transformations. The key to success is not choosing the perfect tool, but implementing the right process, maintaining appropriate oversight, and starting with manageable projects that build confidence and expertise. Remember, AI does not replace need for good engineering judgment. It amplifies it. Use tools that eliminate tedious work so that your team can focus on architectural decisions and business logic that can really matter. And thank you, and I will be happy to take any questions about implementing AI-assisted refactoring in your own organizations.
We are back to the Q&A. Nikolay, thank you so much for your talk. Really, really important, especially migrations are hard. And now with LLMs and AI, everything is being now easier. But of course, we need to have a lot of considerations. And thank you for sharing your insights. We have a lot of questions right now for the audience. Are you ready, Nikolay?
Yeah, let's start.
Awesome. So the first question, which LLM has yielded the best results for you, separated from the IDE or the different terminal tools?
Yeah, so I for a while have been using Cloud for, and it was generally performing quite good, but with recent release of GPT-5 and especially Codex, it just blows it out of the water, and I've switched to it completely. So yeah, it is generally a great tool.
Beautiful. I mean, in my experiences, if the model is good at coding with that specific like technology I'm working on, it's going to be good also for the migration. For the more context you give it, it's the best. We have another question here. On the graph that you had of AI coding assistance landscape, cursor was on the far right for assistant, while agent was on the far left. Cursor also uses agents. It's what they call it. How is this different from your definition of an agent?
Yeah, so in that case, I've basically that graph is based on most of my personal preference, and I've used Cursor quite a while ago, while it was mostly used for auto completions, and right now I'm mostly using it like VS Code with Copilot, and in that case, yeah, it may be a bit outdated, and I will need to update the graph. It is a fair question.
Perfect. Yeah, I think it's a mix. It's both because it supports like pretty good the tab auto completion option, but also you can use background agents and forget about it, which is now my favorite part with these tools.
Yeah, it is that.
Another question we have here for you, Nikolay, is any planning step you put focus on that has been critical in your refactoring? For example, risk mitigation in your plan, dependency graphs, etc.
Yeah, so one thing I definitely wanted to note is hallucination logs, because it is something that you as a team needs to keep. So as far as I know, right now there are no automated tools for that. And what I've been doing is when I encounter stuff like hallucinations and it just basically gets going, I've tried to create just a Confluence doc. And for next iterations, I already do feed it back again to the LLM. So it generally does perform better while not just do same mistakes.
Perfect. One thing that has worked for me is using code mods. There is a lot of different projects that already have created code mods to do that migration, but I let the agent use the code mode for me so it can like check the progress, auto heal, because sometimes it just fails.
Yeah, usually the more groundwork you lay, so the more like tests and test coverage you already have, the better it would perform, because it has that benchmark. It can just check itself again. So if it does a change and it's seen the test is failing, it would update it already by itself. Agents are already capable of that.
Yeah. There is another question here. How do you make sure LLMs focus on fixing components to make the unit test pass versus modifying test cases to make them pass for large refactorings?
Yeah, that is an interesting question, because that happened to me like a few times, and generally, so far I found the only way is to directly specify in one of like you can give instructions in Copilot, and in Cursor you can give instructions to not modify the test if not specifically asked, and it worked for me, but again not 100% of time, because sometimes models and older models like Cloud, for example, they did it sometimes, but it is getting better now as well.
I had some times that it says, okay, the test is failing, so I'm just going to delete it.
Yeah, exactly.
No, this is not what you are
just behaving as a normal programmer at that point.
Please, this is not what we're working on. Okay. A question from Nadim. In your view, which AI-based tool would you say is the best for refactoring code with the least issues?
Yeah,
We
so
already talked about the LLMs, but this time we are talking about the tool.
I would say that Cursor in that case does perform better because when using in agent mode, it just tend to go for a few hours basically, and especially with more sophisticated tools and LLMs like Codex, and it then generally can do pretty much all of the end-to-end migration. Like again, AngularJS to Angular, I have been able to do in Cursor, and it worked perfectly for me.
Beautiful. I have another question here, and I think it's the last right now. It's from Alejandro. Which is the best way to handle context reduction if we reach the limit of our context window in an agentic refactoring workflow?
That is an interesting question. So I would say that first thing, if you're trying to do a context reduction, is to you try yourself identify what is the least impactful context in that case. Because if you can provide, like one of the rules I've had is to provide as much context as possible, but you also need to go overboard with it because you can have that context window overflow. And in that case, what you start to do is you just start from the beginning. You start with the immediate component you would want to refactor its own tests. Then you go to end, and all of the related components. And then as an optional, but definitely one of the important ones is documentation, because it being like having access to well-documented, essentially workflow of the component, it would be able to preserve the behavioral equivalence better.
Yeah, in my experience, it's divide and conquer. If you try to build a huge thing or refactor a huge feature, you might get these context limitation issues. So try to divide that task and specific on one component on one part of that migration at a time. Nikolay, any last comment for the audience here? Because that was the last question from.
Yeah, just probably what I've already said in the presentation itself. Try to start small and try to start already. It is like you probably at that point have one of your tech debt tickets that you have, and so it may not be a full-scale refactoring, but it would just build confidence in you and your team that those tools can be used and it can enhance your performance already. So try to establish it, try to establish more governance in your team, and you will see great results with it.
Beautiful. Nikolay, thank you. Thank you so much for your session and for your insights. And now we continue with this AI Coding Summit and more content that is to come.
Thank you so much.